An object from interstellar space has been observed to visit our solar system.
Humanity has always grappled with the profound question of whether we are alone in the vast expanse of the universe. But what happened in 2017 left the world in awe. A mysterious interstellar traveler visited our solar system, sparking a new set of questions. Renowned scientist Neil deGrasse Tyson has now stepped forward, revealing declassified images of Oumuamua with promise to shed light on our questions and speculations. Could this be evidence of the existence of extraterrestrial life? Join us on this captivating journey as we dive into the mystery surrounding this interstellar object and its possible connection with aliens. Enjoy watching. On February 15, 2013, the city of Chelyabinsk, Russia experienced a rare catastrophic explosion caused by an asteroid. This asteroid moved at a speed of 19 kilometers per second and exploded 30 kilometers above the Earth's surface. The explosion generated a powerful shock wave that caused damage to buildings and resulted in hundreds of injuries. This incident occurred just 4 years prior to our narrow escape from another potentially catastrophic collision with a larger object called Oumuamua. This mysterious object has still not been definitively classified as either an asteroid or a comet. As a result, Neil deGrasse Tyson is here to address all speculations and unveil declassified images of Oumuamua. Before delving into the specifics of Neil deGrasse Tyson's intriguing theory regarding Oumuamua, it's important to understand what we already know about our first interstellar visitor. On October 19, 2017, the Haleakala Observatory in Hawaii witnessed a groundbreaking observation by astronomer Rob Warwick. Initially, the strange flying object was thought to be a comet or an asteroid, but subsequent analysis revealed that it was something spectacularly different. It was the first interstellar object ever detected within our cosmic neighborhood. The object's slanted orbit and impressive speed led scientists to conclude that it originated from beyond our solar system. This remarkable discovery prompted them to give the mysterious object the Hawaiian name Oumuamua, which means a messenger from afar arriving first. Almost immediately, astronomers recognized that Oumuamua displayed irregular fluctuations in brightness that were difficult to explain. They soon deduced that it must have a highly elongated shape, with a length 5 to 10 times greater than its width. To understand Oumuamua's shape, researchers turned to a fundamental tool in astronomy, the light curve. This graph tracked how the object's brightness changed over time as it tumbled through the depths of space. Surprisingly, Oumuamua appeared brightest when observed from its broader side. This unusual behavior led to the estimation that it was approximately 377 feet long, 364 feet wide, and 62 feet thick, based on an albedo of 0.1. This albedo value indicated that Oumuamua reflected 10% of the sunlight that fell upon it, a typical value for a cometary nucleus. The elongated cigar-like shape of Oumuamua raised countless questions and generated a multitude of theories. One hypothesis posited that tidal forces were the culprits behind its peculiar appearance. When an object passes close to a star, the gravitational forces exerted on it can lead to significant stretching, giving rise to elongation. However, this theory faced challenges when trying to explain the precise dimensions and proportions of Oumuamua. At this point, scientists looked closer to home, turning their attention to objects within our solar system, particularly the asteroid 25143 Itokawa. This space rock was visited by the Japanese Hayabusa spacecraft in 2005 and exhibited a similarly elongated shape, resembling either a rough diamond or a potato. By studying Itokawa's surface features and shape, scientists hoped to gain valuable insights into the processes involved in the formation and evolution of such objects. However, while Itokawa shared some similarities with Oumuamua, the interstellar guest remained distinct in its elongated proportions and the absence of a comet-like tail. But it wasn't just Oumuamua's shape that perplexed astronomers. Its acceleration added an even more intriguing layer to the mystery. As it entered our solar system from above the flat plane where planets orbit, Oumuamua ventured remarkably close to the Sun, reaching about 1/4 of the Earth-Sun distance. Following this close encounter, the cosmic wanderer continued its journey below the planetary plane, all while maintaining an astounding velocity of approximately 196,000 miles per hour. To put this velocity into perspective, Oumuamua outpaced any human-made object, including spacecraft and satellites. The speed was so staggering that it led to the hypothesis published in the monthly notices of the Royal Astronomical Society. This hypothesis suggests the interstellar object Oumuamua likely came from a binary star system, where the gravitational influence of two stars would have more readily ejected the interstellar traveler from its home system. It further proposes that gravitational interactions within binary star systems could eject objects at high velocities. The lead author, Alan Jackson, an astronomer at the Center for Planetary Sciences at the University of Toronto, said, "For rocky objects like Oumuamua, more than 95% of them likely come from binary systems. If this were the case, Oumuamua's swift journey could be attributed to the gravitational forces exerted by the stars, propelling it on its interstellar voyage." One of the most fascinating and controversial suggestions is that it could be a hydrogen iceberg. Yes, you heard that right, a hydrogen iceberg. But how could something so exotic exist in the vast expanse of space? The idea stems from Oumuamua's peculiar characteristics. Now, why hydrogen? Hydrogen is the lightest and most abundant element in the universe. Some experts speculate that Oumuamua could be wrapped in a thin layer of molecular hydrogen, which would explain its strange shape. This hydrogen ice could insulate and protect a denser core, such as metal or rock. The theory goes that as Oumuamua travels through space, the hydrogen layer could gradually sublimate, producing the unexpected acceleration and spin observed. This notion is far from proven, and skeptics argue that hydrogen wouldn't be stable in the harsh environment of space. But it's precisely this kind of bold thinking that keeps science exciting. Another intriguing hypothesis postulates that Oumuamua's extraordinary velocity might be attributed to encounters with celestial bodies within its native star system. In this scenario, the interstellar traveler would have come into close proximity with planets or other substantial objects, which in turn acted as cosmic gravitational slingshots, endowing Oumuamua with the necessary boost for its incredible speed. This gravitational assist is a well-established phenomenon in space exploration and is frequently employed by interplanetary missions to conserve fuel and gain momentum. Just as spacecraft use the gravitational pull of planets to alter their trajectories and achieve higher speeds, Oumuamua might have harnessed these celestial interactions to accelerate its journey across the cosmos. However, much more research is required to determine the likelihood of such encounters and their contribution to Oumuamua's exceptional velocity. Interestingly, there is a growing demand for insights from renowned experts like Neil deGrasse Tyson regarding the velocity of Oumuamua. But at that time, Neil deGrasse Tyson was in the midst of developing his own theory, which we will soon explore in detail. What does Oumuamua's composition say about its origin? One of the most fascinating aspects of this cosmic traveler is its composition. Studies have revealed that Oumuamua boasts a thick outer layer akin to a cosmic shell composed of carbon-rich materials. This outer layer solidified during its extensive journey through interstellar space bombarded by cosmic radiation. Beneath this protective exterior lies Oumuamua's remarkably dense core, primarily comprised of rock, possibly with traces of metal. What sets it apart is the absence of water or ice, making it distinct from typical comets or icy celestial bodies. Adding to its allure, Oumuamua's surface exhibits a reddish tint, a result of eons of exposure to cosmic rays. The elongated shape of Oumuamua has led researchers to speculate about its origin. Some suggest that it could be a fragment of a larger celestial body. If Oumuamua broke off from a larger object due to a collision or other violent event, it may have gained substantial velocity during the separation process. This implies that Oumuamua's high speed is not inherent to its nature, but rather a consequence of past events. While comets can attain similar velocities, they typically exhibit residual gases and dust due to their volatile composition. Oumuamua, however, displayed none of these characteristics, setting it apart from known cometary objects. Comparisons to asteroids and rocky objects orbiting the Sun further highlight Oumuamua's uniqueness. Most asteroids in our solar system move at significantly slower speeds than Oumuamua. For example, the well-known asteroid Ceres has an average orbital velocity of less than a fifth of Oumuamua's estimated speed. This stark difference underscores the exceptional nature of Oumuamua's velocity and its divergence from familiar solar system objects. Some experts propose the possibility that Oumuamua might not be a natural occurrence at all. Instead, they speculate that it could be an artificially crafted object, meticulously created by an advanced extraterrestrial civilization. Yes, aliens. According to this intriguing theory, Oumuamua could be part of an incredibly advanced alien spaceship or equipment designed for exploration. Its elongated structure could enhance its resilience during interstellar travel, while its propulsion system might enable precise maneuvering through the cosmos. Notably, Avi Loeb, an Israeli-American theoretical physicist and astronomer, has been a prominent advocate of this hypothesis. Loeb even controversially suggested that Oumuamua could be an artificial object or a piece of alien technology. He pointed to its peculiar properties, such as its elongated shape and unusual acceleration, as potential indicators of an artificial origin. Loeb's hypothesis has sparked widespread discussion and debate within the scientific community. However, it's essential to acknowledge that many scientists and astronomers remain skeptical of his claims. The prevailing view among most experts is that Oumuamua is likely a natural object, such as a comet or an asteroid, and its unusual properties are the result of natural processes. Researchers, including Wesley C. Fraser, have been diligently studying Oumuamua's puzzling rotation. By analyzing brightness measurements from multiple telescopes, they have determined that no single rotation period can account for the observed variations in brightness. Instead, Oumuamua seems to be tumbling in an excited rotational state, a peculiar and irregular motion that has never been seen before. This irregular rotation has left scientists scratching their heads since its discovery. Astronomers have made significant observations that shed light on Oumuamua's spin. It completes a full rotation every 7.3 hours, which is relatively fast compared to other objects in our solar system. The varying brightness of Oumuamua as it spins suggests that different parts of the object reflect sunlight to varying degrees. This irregular rotation has led to various intriguing theories. One hypothesis is the spin-induced outgassing theory. According to this idea, volatile substances beneath Oumuamua's surface are exposed to solar radiation as the object tumbles through space. This exposure causes the volatile materials to vaporize, creating tiny gas jets. These jets act as thrusters, imparting a torque on Oumuamua and causing it to spin irregularly. This implies that Oumuamua's composition may contain volatile materials that sublimate under the influence of solar radiation. However, further studies are required to validate this mechanism as the cause of Oumuamua's peculiar rotation. Another theory suggests that Oumuamua's tumbling motion is a result of a past collision with another object. It is plausible that a high-speed impact distorted its shape and set it into an irregular spin. This collision could have occurred in Oumuamua's home star system before it was ejected into interstellar space. However, due to limited observational data, the exact nature of such a collision and the object involved remain speculative. Detailed analysis of Oumuamua's shape, composition, and surface features could provide valuable clues supporting this theory. To gain further context on Oumuamua's peculiar movement, let's consider other celestial objects that exhibit similar behavior. One such object is the asteroid 4179 Toutatis. Discovered in 1989, this elongated asteroid also displays a tumbling motion similar to Oumuamua. Scientists have proposed several theories to explain Toutatis's erratic rotation, including the Yorp effect. According to this effect, sunlight exerts a torque on the object due to uneven thermal radiation. Over time, this torque alters the asteroid's rotation, leading to its irregular tumbling motion. While this mechanism could potentially apply to Oumuamua, its specific role in its rotation remains uncertain. Interestingly, another celestial body with an irregular rotation is Comet 67P/Churyumov-Gerasimenko, often referred to as 67P. Discovered on September 11, 1969, This comet orbits the Sun and displays a distinctive shape and unique movement. It consists of two distinct lobes connected by a narrow neck, resembling a rubber duck or a bowling pin. Scientists have designated the larger lobe of the comet as the body and the smaller lobe as the head. This comet follows an elliptical orbit and completes one revolution around the Sun in approximately 6.45 years. It belongs to the Jupiter family of comets, indicating that its origin can be traced back to the Kuiper Belt, a region beyond Neptune that is populated by icy bodies. However, researchers believe that Jupiter's immense gravity caused gravitational perturbations that captured Comet 67P into its current orbit. This previously studied comet experiences changes in velocity and distance from the Sun. In the case of Oumuamua, scientists speculate that the outgassing of volatile substances from the comet's surface plays a significant role in its tumbling motion. As solar radiation interacts with the ice on the comet's surface, it vaporizes, creating localized jets that act like thrusters and alter the comet's rotation. The resemblance between Oumuamua and these objects suggests that there may be underlying mechanisms responsible for their unusual spins. Further exploration and detailed analysis of these objects can provide valuable insights into the nature of Oumuamua. The origin of Oumuamua has also sparked much speculation. Some scientists propose that it could be a fragment of a larger body that was ejected from its home star system due to gravitational interactions or a catastrophic event. This ejection might have imparted an initial spin on Oumuamua, which has persisted throughout its interstellar journey. The exact process by which Oumuamua was ejected and its subsequent trajectory remains uncertain, highlighting the need for more data and further research. It is also possible that Oumuamua is a result of a collision between two objects in a distant star system, with the resulting debris being flung into interstellar space and Oumuamua being one of the fragments caught in our solar system's gravitational pull. However, these theories remain speculative without further evidence. Detailed analysis of Oumuamua's composition, isotopic ratios, and surface features could provide clues about its origin and shed light on the mechanisms involved in its peculiar spin and movement. The absence of visible emissions observed in Oumuamua puzzled scientists even more. This lack of visible emission eliminates the possibility of Oumuamua being a typical comet or asteroid, presenting an intriguing puzzle that requires further investigation. There is a possibility that Oumuamua's lack of emission could be explained by it being a dead comet, where the icy composition has already vaporized as it approached the Sun, resulting in the absence of an emission trail. What were Neil deGrasse Tyson's stances on the declassified images? Neil deGrasse Tyson, a renowned astrophysicist and science communicator, has a deep interest in space exploration. Throughout his career, Tyson actively advocated for the advancement of space science and played a pivotal role in popularizing astronomy. In relation to Oumuamua, Tyson allowed himself to think beyond the borders of contemporary science as he believed that Oumuamua may represent more than a mysterious object flying through space. While it could be a naturally occurring object, it could be a plot from extraterrestrial beings giving a nod to humans and urging us to explore. This intriguing concept suggests that the universe is far more complex than our current understanding. It raises questions about our readiness to decode such potential messages and what implications they may have for the future. Tyson takes his speculations further, contemplating the idea that Oumuamua might serve as a test of our technological and scientific progress. Tyson highlighted how space exploration drives technological innovation on Earth. The challenges posed by the study of Oumuamua have spurred advancements in observational techniques, data analysis, and collaboration tools, setting the stage for more effective space exploration in the future. It has also prompted more billionaires and government organizations to invest in space-related research. The pursuit of understanding phenomena like Oumuamua can lead to the development of new technologies and techniques that benefit not only astrophysics, but also various other scientific and technological fields. The swift scientific mobilization triggered by Oumuamua's brief visit to our solar system tested the collaborative capabilities, data-sharing prowess, and resource pooling of the global scientific community. According to Tyson, It was a test of our ability to unite in the face of a sudden cosmic event and raises awareness of the lessons we can learn for future encounters with interstellar visitors. But Tyson did not end there. He explored the possibility of a broader message within Oumuamua. If it was intentionally sent our way, the test may not only involve detection, but also interpretation. Can we decipher any encoded message or signal embedded within its structure or behavior? And if so, how should we respond? Tyson's stance on international collaboration emphasizes that the frontiers of space exploration transcend national boundaries. The study of celestial phenomena, like Oumuamua, is a collective endeavor that requires expertise, resources, and infrastructure from across the globe. Oumuamua's sudden appearance was a universal call to action, prompting astronomers, astrophysicists, and researchers worldwide to unite in their curiosity and pursuit of knowledge. Neil deGrasse Tyson referred to his book, "The Sky is Not the Limit: Adventures of an Urban Astrophysicist," written almost a decade ago. He actively encourages the public to gaze upward and explore the marvels of the cosmos, regardless of their location. Tyson believes Oumuamua serves as a reminder that celestial events and discoveries are accessible and captivating for people from diverse backgrounds and geographical areas. He invites everyone to contemplate and formulate their own hypotheses about Oumuamua and future celestial phenomena. Tyson's perspective, which aligns with NASA's commitment to scientific excellence, underscores the imperative of consistently enhancing our tools and capabilities to ensure preparedness for forthcoming interstellar encounters. Tyson's viewpoint emphasizes the importance of continuously improving our technological capabilities to be prepared for future encounters with interstellar phenomena. This involves enhancing our detection methods and optimizing instruments and telescopes to quickly identify and track celestial objects like Oumuamua. Thanks for watching another episode of Beyond Discovery. Check out the video you see on your screen right now. It's unbelievable.